All right, this is pre-calculus. Today is October 25th, 2018. I'm Mr. Sindel, and Riley right now is sick, so I'm whispering right now also because he is sleeping. So, this is going to be done on your whiteboard. I want you to write the general form of a sinusoidal function. So that general form is y equals a times, and then blah, blah, blah. You should be able to remember that general form. And then I also want you to list how each variable affects the function. So do that on your whiteboards now. And before you pause the video, I just want you to know that there's a binder check tomorrow, so make sure that you have your binder perfect. I'm going to be checking that off tomorrow. So go ahead and pause the video now, and I will do the answers for this when you come back. Alright, so you've unpaused the video now. So it's going to be a times, and it doesn't matter if you write cosine or sine here. I just usually write sine. If you wrote cosine, that's fine. Cosine or sine of bx plus h, and that is going to be plus k. So those are the normal variables that we use. Again, any letter will really work here, and the important part is whether you know what they do. So a, this affects the amplitude. Amplitude. B, that affects the period. And how does it affect the period? You should also know this too. It affects the period because you know that the period is going to be 2 pi divided by whatever that b is, absolute value, because it's always positive. H, we know, we don't really talk about h, but just as a subnote, h does affect the horizontal shift, which means how much left and right shifted. We usually don't shift our functions for our homework though. It's just nice to know what it does. I won't ever test you or quiz you on it. And then k, that's your vertical shift. Vertical shift, and you might be saying, wait, what? And that's because the name we normally associate with him is midline. This shifts the entire function up or down, which changes the midline by making the midline go up or down. All right, cool. So that's the warm-up. Make sure that you have the notes out in front of you. They look like this. If you don't have the notes, they are on Google Classroom as well. So the general formula, again, it's right here. We're going to add this in our notes again because we did it on the whiteboards just to get us warmed up. Now we're actually going to write it down. So A, again, this affects the amplitude. So that's our amplitude. My next color I'm going to do right here. This is going to be our period. I guess if I'm being closer to this, I guess this one should be our yellow. I'm going to do this one in green. So this is going to be our period. Again, it's 2 pi divided by whatever b was. Make sure it's positive absolute value. H, we're not going to care so much about, but we'll just add it to our notes if you want it. That's the horizontal shift, how much it goes left and to the right. And then k, that is our important one. That's going to be our midline, or our vertical shift, how much it's going up or down. Okay, so this is all review still. I want to do some review of the graph. So on the graph, again, our amplitude is how far you are away from the midline. So this is the amplitude, is this distance from here to here. That's the amplitude. We, of course, have the midline, which is this yellow line. Midline. Amplitude is the same distance from here to here. It's always positive. Horizontal shift, we're not going to worry about. So we have all the things listed aside from period. So we know that from here to here, maybe I can do a little bracket. From here to here, we know how much of the period that is. That's 1/4 of the period. I'm just going to say 1/4 of the period. From here to here, that's another quarter of the period, which means that altogether from here to here is a total of half of a period. And that's all I really need to know, because I know that that's another quarter from here to here. It's another quarter from here to here. But as long as you know these first two facts, you're good. The other thing I'm going to add to these notes that we already reviewed, but it's kind of nice to just have on here, is where sine and cosine start. So sine always starts right here. This is where sine starts. And then cosine will always start right here. This is where cosine starts. So cosine starts at a maximum, and sine starts at the midline. So in the problems that we're going to have in the future, and I'll be saying this probably again, if I start at a minimum it's still going to be cosine. It just means that that cosine has a negative amplitude, which means it starts down here and then goes to the midline. If you start at the midline and go to a maximum, it's positive sine. If you start at sine and go to a minimum, then the sine has been reflected over that midline, which means it's a negative amplitude. If that doesn't make sense, I'll re-explain it with an example. It'll make more sense later. All right, we have two examples. We have this first example and the second example on the back. So, and just kind of relating this to our previous lesson, lesson 9-8. 9-8 was looking at a graph and creating an equation. Now, instead of looking at a graph, we're just looking at the data that it provides us. I guess actually 9-8 was constructing it. So now I guess we're just going backwards with this lesson. Instead of us making these 2 points and finding, or us making those 2 points to get the equation graphed, now it's giving the 2 points and we're making the equation. There, I said it right finally. So we only have 2 pieces, well, I guess 4 pieces of information. We know that you start with the midline, and the midline is 0, 5, and then you have a maximum at 2 pi over 9. So if I'm starting at the midline, that will give us some information. And usually the order that I do this is parent function, figure out if it's sine or cosine, then figure out what the amplitude is, figure out what the value of A is, then figure out what the period is, figure out what B is. We don't ever have an H, so don't worry about him. And then we're finally going to figure out what midline, again, that's our K up here. So we're going to find what each of these letters is. And you can go in order. You can find the period first and then do the amplitude. It doesn't really matter. This is just the way that I do it. All right, the parent function. So I'm starting at 0, 5. And that's the midline. So if I'm starting at the midline, that's the key part. If I'm starting at the midline, am I starting with a sine or am I starting with a cosine? And you can clearly see, yeah, it is a sine. We're starting at the midline, so I know I'm going to be dealing with sine. So from that information, I know that the parent function is sine of something. All right, the amplitude. Let's go ahead and figure that out. I think amplitude and period are probably the 2 hardest things for different reasons. Midline is pretty straightforward. It can be sometimes a little bit tricky to find, but amplitude and period I would consider the hardest parts of this. So please be paying extra attention to number 2 and 3. All right, amplitude. We have a midline at 0, 5 and a maximum at 2 pi 9. So the amplitude is how far I go from the midline to the max or from the midline to the min. Here I have a midline and a max, so I need to figure out the y distance, the height distance between those 2 points. So I'm looking at the y coordinates here. I'm looking at 5 and I'm looking at 9. How far did I travel? And you can say, oh, well, Mr. Sindel, 9 minus 5 is 4. And I say, yes, you are correct. It is 4. But you also need to check now, is it a positive 4 or is it a negative 4? And you are probably screaming at the computer, Mr. Sindel, you told us amplitude is always a positive number. It can never be negative. And I say, yes, if I'm talking about amplitude in the official sense, like you are thinking, it is always a positive number because it is a distance. But in an equation, it can be negative, and that represents when the amplitude is flipped, reflected over this midline. That can happen. So we can have a negative value of A. A just affects the amplitude. It isn't the amplitude because amplitude is always positive. So the moral of the story, it can be negative. Let's check. If it's negative, that means instead of going from a midline to a max, I would go from midline to a minimum. So am I going to a minimum or am I going to a maximum? And let's check here. I go from the midline to a maximum. So if it's going to a maximum, it's just positive. It's just, you have to check it every single time. I'm going, and it's positive, so it's positive 4. And what variable is 4? 4 is our A. So A is equal to 4. All right, our period. I guess these could have been closer together. I was thinking I might write extra stuff, but it's nice to have period. So the period is how long it takes for the entire function to repeat. So from here, this point, to this point, that's one full period. Now how can I tell what the period is? So it tells us that I go from a midline to a maximum. That means I go from a midline to a maximum. I've gone this distance here. And because we have it in our notes, we already know that's going to be 1/4 of the period. But in maybe another example, if I go from a midline to a midline, then I'm doing half of a period. In this case, I'm doing 1/4 of a period. So I know that in 1/4 of a period, I've gone a distance from 0, I guess I should be using my actual tablet, 0 to 2 pi. This distance between 0 and 2 pi, which is just 2 pi minus 0, which is 2 pi. So this distance 2 pi is 1/4 of the period. So how do we find the full period? Well, I can create an equation if you really want me to. So I can say that this distance of 2 pi is, remember, is translates into an equal sign. 2 pi is 1/4 of the period, which means to find the period, I multiply by the reciprocal, or I multiply both sides by 4. And I can just do that really quickly. Multiply both sides by 4 here and here. And then I'll see, oh, yeah, period, the 4's will cancel out. This 4 and this 4 cancel out. And then 4 times 2 pi, that means my period is equal to 8 pi. The problem with this is I'm not looking for p. I'm not looking for the period. I'm looking for b. The period is 2 pi over b. So we're going to have to do a little bit of math here. If the period is 8 pi, I know that 8 pi, the same 8 pi, needs to be equal to, and then this is just the formula, 2 pi, oh, got some lag there, 2 pi divided by b. That's our formula. It should be absolute value of b. I'm going to drop it because we know that it needs to be a positive. Or, yeah, it's always just going to be a positive for us. So how do we solve for this? Well, the answer is I can switch these two. I can multiply both sides by b. I'm showing you the long way, and I'm going to show you the shortcut in a sec. I'm multiplying both sides by b to get rid of b there and get b up there. So now b times 8 pi is equal to 2 pi, and then I'm going to divide both sides by 8 pi. So I'm going to, let's choose green here. I'm going to divide both sides by 8 pi. 8 pi, divide this by 8 pi, and what that will do is it will eliminate my 8 pi over there and bring it down here. Now b, the letter I'm trying to find, b is equal to 2 pi over 8 pi. And 8 divided by, yeah, the pi's will cancel out, so I should just say pi's cancel out. 2 divided by 8 simplifies to 1/4. So there's my answer. B is equal to 1/4. That's what I'm trying to find, but there is a shortcut, and I'll show you the shortcut right now. If I have this original equation, 8 pi is equal to 2 pi over b, the shortcut is just switch these two. You're allowed to switch those two. It's the same thing as multiplying by b and dividing by 8 pi, but you're allowed to switch those two. So if I switch them, b is up here and 8 pi is down there, pi's cancel out, you're left with 1/4. So in the future, we're just going to be switching them. That's our shortcut. All right, we have our parent function, we have our a, we have our b, we don't deal with h. So a, sine, b, x, don't deal with h. We're just left with midline. That's the only thing we have to find. We have to find k. So how do we find midline from this? Oh, it just tells me it intersects its midline at, remember, midline is always the y-coordinate, and if you forget that, we can write this, it's always the y-coordinate. Period is always the x-coordinate. Amplitude is always going to be a y-coordinate. So I'm looking for the y-coordinate of the midline, and it tells me right here the midline is at 0, 5. So the y-coordinate is 5, therefore the midline is 5. So my k is going to be 5. I'm done. I have the equation. So here I go. I need to write the formula. The formula is y equals a. Which one was a? A is 4. Oh, got some lag there. 4 times my parent function, sine. Set up my parentheses. I need to do b times x. Well, what was my b? My b was 1/4. So I'm going to say 1/4 times x. You can write x divided by 4 or 1/4 of x. Both are correct. I'm just going to choose to write it this way so we can see what the value of b was. Then I need to say plus k. Plus is 5. Plus 5. There is my final answer. Box it. This is what you will be entering into Khan Academy for the homework set. Alright, that was kind of difficult. I'm going to give you an even more difficult problem for our next example, so make sure you really understand everything here. Maybe you need to rewind or pause. That's the beauty of YouTube. Or on the back side, I should hear paper flipping over. The graph of the sinusoidal, I should say function here. Did I not say function up here? Of a sinusoidal function, okay. I need to write function here. I'll make a note for myself for next year. Function has a minimum point at 0, 1 and its maximum point at 4, 7. Okay, so this is different. Last time we had a midline and a maximum. Now we have a minimum and a maximum. I wonder how that's going to change things. And we have the points. I'm going to go ahead and unline the important part. That's a min, that's a max, and we have the point, and we have the point. We have 4 pieces of information. We're writing the formula where x is entered in radius. We always assume that because we're always doing 2 pi divided by b instead of 360 divided by b. That's why we know we're in radians. All right, the parent function. Are we sine or are we cosine? Again, the way that we know is sine will start at the midline and cosine will start at an extremum. It'll either start at a maximum or a minimum. Where are we starting here? We start on the y-axis, because x is 0, at the position 1. Is this point a minimum, maximum, or midline? Oh, it says it's a minimum. If it's an extremum, if it's a minimum or a maximum, that means our parent function is going to be cosine. So our parent function is a cosine of something. How do we figure out our amplitude? Again, our amplitude is our distance from the midline. The distance from the midline. And it can be negative or positive when we're trying to find the actual value of a. We're trying to find what a is equal to. So this is important. A cosine will always start here at 1. If I was looking at the graph of cosine, this would be my y-axis, this would be my x-axis. That's what it would look like. But on this problem down here, it's telling me that I'm starting at a minimum on 0, 1. My minimum, technically it's up here at 1, but my minimum would be starting at it, like down here essentially. I know it should be positive technically, but this is a better illustration of what's happening. I'm starting at a minimum, and then I'm going to be going up to a maximum, which means I'm flipping over this midline. If I start at a minimum, that means I have a negative amplitude. If I'm going to a minimum from sine, I have a negative amplitude. So this is an example where I have a negative value of a. So let's go ahead and undo all that so it still look nice. That means my value of a here is going to be a negative number. And what is that negative number? So I need to figure out, again, amplitude, I'm always thinking about the y-coordinates. I went from a minimum of a y-coordinate of 1 to a maximum of 7. So my total distance here, my total distance from a, I guess it's from a minimum down here to a maximum, this total y distance I'm going to find, and then I'm going to divide it by 2 because I only care about the amplitude, which is half of it. So the total distance between 7 and 1 is 6, and then half of 6 is 2. So my amplitude is 2, and my value of a is negative 2. If you need to replay that video, go for it. But that is pretty confusing how to get negative 2. I hope that we can understand how to get that. All right, the period. Again, I know that the period, I'm going to be looking for the value of b, and I know in order to find the value of b, I first need to find the period and say that the period is equal to 2 pi over b, which means my value of b, and then this is I should have done a red star here. This is a red star. This needs to be in your notes. Here's a formula to find the value of b. Since I can switch these two right here, my value of b is going to be equal to 2 pi divided by whatever my period is. Okay, so let's find the period. Again, the period represents how long it takes to repeat the function to get from this point to this point, but they'll only be giving us midline to an extremum, or midline to midline, or extremum to extremum. So in this case, what we're doing is we're finding this distance right here, which is also 1/2 of the period, 1/2 of the period. So I'm right here, I went, and we're talking about the x-coordinates here, I went from 0 to 4 to go from a minimum to a maximum, and that's half the period. So if half the period, it took 4 units, that means the full period should take 8 units. I know my value of p. My value of p, and I'll write this in green, my value of p is 8. Ooh, that was loud. My value of p is 8. So if I know my value of p, then I can use my fancy formula over here, 2 pi divided by the period, 2 pi over 8, and I can just get 2 over 8, that simplifies to 1 over 4, so 1/4 of pi. So my value of b, I'll write this down here, my value of b is going to be 1/4 of pi. I still have the pi, it didn't get eliminated this time. I don't know why I put parentheses, I don't need those. Alright, and then midline. This guy is a little bit tricky in this one because it didn't explicitly give it to us, but we know that the midline is halfway between the minimum and the maximum. It's the midpoint between the y-coordinates of the minimum down here to the maximum. So I'm going to find this total distance again, and then take half of it to get the midline. So I always scroll down too far. So I go from 1 to 7, that's a total distance of 7 minus 1 of 6. And then half of that is 3, my midline is 3. So k is equal to 3. And then I need to put all these pieces together. So my function is y equals -2, that was my value of a. Then I do my parent function. My parent function was cosine. It's going to be b times x. So it's going to be 1/4 pi, 1/4 of pi times x. Or I could do pi over 4x. Or pi x over 4. All of those are fine. Then I need you to add the value of k, so plus 3. And there I have my final equation. I should make a note before I end the lesson that you really need to have this stuff mastered by the next lesson, because the next lesson we're doing the same exact things. We're basically given a minimum, maximum, or midpoint with 2 points, but it's going to be a word problem, and we're going to make formulas from that word problem. So it's building off of today's lesson. Alright, so what I want you two to do right now is to finish your summary and then go on Khan Academy and work on that one problem set. And just to keep, to make sure we know what's going on, oh wait, it's actually right here. On our unit guide, we just did 9-9, constructing sinusoidal functions. 9-10 is going to be tomorrow. That's going to be on Friday, which means our quiz is going to be on Monday, and our test is going to be on Tuesday. So it's going to go very fast. Make sure that we're ready for the quiz on Monday and the test on Tuesday.